We now take up the next problem. It is problem number 50, which says two blocks of masses M1 and M2 are connected by a spring of spring constant K. As shown in the figure, the block of mass M2 is given a short impulse so that it acquires a velocity v0 towards the right. This is the velocity v0. Now, what will happen if M1 is fixed and if I give a short impulse to M2, the spring will be stretched. And of course, thereafter, the spring will come back to its earlier position, or it will be further stretched. Whatever. First, it will be stretched and then it will come back. The question is find the velocity of the center of mass. And there is a second question. We shall see the second question here. Now, what is the velocity of the center of mass? Now, if the center of mass velocity, this part is very, very easy. The center of mass is, of course, it has got a center of mass as per the calculation of center of mass. If the center of mass velocity is the velocity of center of mass is equal to v, velocity of center of mass is v, then the momentum of the center of mass, then momentum of the center of mass is equal to m1 plus m1 plus m2, the total mass, minus multiplied by the velocity of the center of mass v. So this is the momentum. And this momentum definitely will be the initial momentum of A and B. So this momentum, I am writing at this, everything, this momentum of the center of mass is equal to initial momentum, initial term of 1 and M2. Now, initial momentum of M1 is M1 0, because nothing has been done with M1. M1 multiplied by 0. Multiplied by 0 plus M2 has been given a velocity of V0. This is equal to M1 plus M2 into V. So, the momentum of the center of mass, velocity of the center of mass equal to V is equal to M2 by M1 plus M2, M2 divided by M1 plus M2. This is one answer, answer A. Now let's go to the part B. Part B asks, also find the maximum elongation that the spring will suffer. Obviously, when you apply a force to this, there will be elongation. What is the maximum elongation? Right? Now, here there is a point. When a spring is maximum elongated, this you have this you have, I think you have learned in your kinematics or some other chapter. If you compress a spring, there is a limit to which the spring can compress, because when the loops of the spring they touch each other, you cannot compress it further. Similarly, there is also a limit to a spring, limit to which you can stretch the spring. If you stretch it further, then the spring will become a wear and it will be no more a spring. There is a maximum and minimum limit. And obviously, when, this is very important, when the spring is stretched to its maximum limit, then what happens? Then the spring appears to be a solid string. This you can also, you will agree from your common sense. If you stretch the spring to a maximum limit, it is as if a solid piece of wire. At that time, when the spring is stretched to its maximum limit, then the spring and the two bodies, that means M1 and M2, behaves as a rigid body, behaves as a rigid body. This is very important in this particular. It behaves as a rigid body. When it becomes a rigid body, and at the time, let me write it, continue this way, and then velocity of M1 will be equal to velocity of M2 will be equal to velocity of the center of mass, because it is a rigid body. So all the velocities are same, right? This is a very important argument here. Now, what is the velocity of the center of mass? And the velocity of the center of mass has been already obtained as m2 by m1 plus m2 v0. So, the kinetic energy of the center of mass then is equal to half, since it is center of mass, so sum of the two masses of m1 plus m2 into, right? And this V is equal to this V. This is the kinetic energy of the center of mass. And where from this center of kinetic energy has come? This is the kinetic energy has come at the expense of the initial kinetic energy of M2. So let us write initial kinetic energy of M2 is equal to half M2 V0 square. Initial kinetic energy half M2 V0 square. Also, when the spring is stretched, so let us write also when the spring is stretched to its maximum, spring is stretched, the spring acquires a potential energy. Stretched, its potential energy is equal to half k x square. When x equal to the stretch. X is the length by which it has been stretched, or elongation. The X is the elongation that we have to find out. I repeat here once again, when the spring is maximum stretched, then there are two elements of energy. One is the potential energy of the spring, and second is the kinetic energy of the center of mass. And sum of these two must be equal to the kinetic energy of the body M2 due to its velocity v0. So we can write here kinetic energy, initial kinetic energy of M2 is equal to kinetic energy of the center of mass plus potential energy of the spring, because there is no other source of energy. So what we get? First, initial kinetic energy of M2 is half M2 V0 square is equal to kinetic energy of the center of mass is half M1 plus A square plus half K X square. So this is the basic equation which now we have to solve. Half K X square. Right? Now, from this we find that this is the basic equation which we have to solve. Now from here, we first remove half, half, half. And we do a little bit of transposition of the left and right. From here, what we get? Kx square, because we have to find out x finally. Kx square is equal to m2 v0 square, m2 v0 square minus m1 plus m2 v square. So m1 plus m2, and what is v square? Minus m1 plus m2 into v square. Right? Now, this here, center of mass equal to, we have to now find out the m1 plus m2, m1 plus m2 into v square. Now, v square is, v is lifted upward, we have left it upward. V is given here, m2 divided by m1 plus m2 into v0. Coming to this, v square is m2 square v0 square divided by m1 plus m2 whole square. Therefore, kx square is equal to m2 v0 square, m2 v0 square minus, here we have minus this m1 plus m2 together and is squared. So we are remaining with this. So here we have m2 square v0, m2 square V0 square divided by M1 plus M2. Take V0 within outside the bracket. Then we have denominator remains same, M1 plus M2. This M2 multiplied by M1, so M2 M1 plus M2 square, and I have another minus M2 square here, minus M2 square. This is equal to V0, this minus M2 square and plus M2 square gets cancelled. So what we have, V0 into, this was V0 square, this was V0 square, V0 square into M1 M2, M1 M2 divided by M1 plus M2. Now on the left hand side, I had K and the square. So what I have, X equal to, then V0 under root will be V0 only. I have M1 M2 divided by M1 plus M2, and there is a K here, this whole thing under root, and under root of V0 square is V0. So this is the value of X, which as they said, is the maximum elongation. This is the maximum elongation, which is the value of X, right? Now we shall go to the next question. We now go to problem 51. That is the next problem. And we take this problem one after the other, because problem 51, it says at the very beginning that consider the situation of the previous problem. So what was the previous problem? Let's have a look at that. The previous problem, problem 50, was two blocks of masses M1, M2, and a pulse was applied to M2 so that it had a instantaneous velocity of V0. And then we found out the total extension of the spring. Here it says, suppose each of the block is pulled by a constant force F instead of impulse. That is, they are pulled by a constant force. Then find the maximum elongation that the spring will suffer and the distances moved by the two blocks. So that is why the author of this book has given these two problems one after the other. What happens? By the problem, each of these blocks is given a force F, constant force F, right? Now, if it is given a constant force F, then obviously block M2 will come towards right. Let us draw a line here. Say block M2 may come here, and let us say the distance traveled by M2 is x2. Block M1 also will be shifted, and let us say the shift in M1 is x1, right? And the question asks, suppose each of the block is pulled by a constant force F instead of an impulse. So now this force will definitely do some work on this body, because we know work done is equal to force multiplied by displacement, and work done here on M2 is force into X2, and work done here is actually force into X1, right? And what they want to find out? Find the maximum elongation of the spring. That means with this force, if we pull them, what maximum elongation happens in the spring, and the distances. What are the values of x1 and what is the value of x2? And the maximum elongation of the spring. See here, total work done by the forces will be equal to increase in potential energy of the spring. The spring is increased by x1 plus x2, right? The spring is elongated. The spring is stretched by x1 plus x2. String is stretched by x1 plus x. So what is the increase of potential energy of the spring? So increase of potential energy of the spring. Here actually, though I am writing potential energy of the spring, mind it, here potential energy of the entire system, because as per the question, there is nothing outside this system, there is no external force. But anyway, even if we write potential energy of the spring, that is good enough. Increase of potential energy of the spring is equal to half k x1 plus x2 whole square, right? And this increase in potential energy of the spring happens due to the work done by the force F on M2 and by the force F on M1. So, and work done is equal to the force F into x1 plus x2. Therefore, F x1 plus x2, F into x1 plus x2 is equal to half k x1 plus x2 whole square. From here, we can easily find this. This is x1 plus x2 on the left-hand side. On the right-hand side, x1 plus x2 whole square. So I am left with x1 plus x2 on the right-hand side. So x1 plus x2 is equal to 2f by k. Is equal to 2f by k. This is one relation that we shall need. Let's say this is relation 1. And to find out the value of x1 and x2, I need another relation. That relation is very simple. What is the momentum of B? Momentum of M1. Momentum of M1. Momentum of M1 is equal to M1F. Momentum of M1 is equal to this is I have actually jumped a step. Let me do that step for you also. That will be easier. say force applied, because say force applied, say the forces are applied for a time del t. Then what is the velocity of m1? So velocity of m1 equal to x1 by del t, and velocity of m2 equal to x2 by del t. And velocity of m1 is v1, so I can write here that is v1 is equal to x1 by del t, and v2 equal to x2 by 50. Let us write it here also. This velocity is v2, this velocity is v1, so that you are not confused. This velocity is v1. So we have got the velocity of v. So then momentums, then their momentums, their momentums p1, momentum p1 is equal to mv, p1 is equal to m1 x1 by del t, and p2 is equal to del t. Now mind it, the system was at rest beginning, then the force was applied, by which the two momentums p1 and p2 has been generated, and also the main point is these two velocities are in opposite direction, so the momentums are in opposite direction. In opposite direction. In opposite direction. If that is so, then P1 and P2 will be same. So P1 has to be equal to P2. In fact, by looking at the system, you can say P1 is equal to P2. But to remember the matter, these steps maybe you can note down. P1 is equal to P2. So this is P1 is equal to P2. Therefore, so P1, if P1 is equal to P2, P1 is M1 X1 by del T, P2 is M2 X2 by del T. So M1 X1 will be equal to M X2. M1 X1 will be equal to M2 X2. Say this is relation 2. Then we have to just solve between the relation 1 and solve between the two relations 1 and 2. From 2, from equation 2, we can write, from equation 2, what we find, x1 is equal to m2 upon m1 x2, m2 upon m1 x2. Then we go to relation 1. Then from relation 1, what we get, x1 is m2 by m1 x2, plus we have got another x2 is equal to 2f by k. From here we get here m1, m2 x2, m2 x2 plus m1x2, m2x2 plus m1x2 is equal to 2f by k. From there we get the value of x2. So x2 is equal to 2f 2f by k by multiplied by m1 multiplied by m1 divided by m1 plus m2. So this is the value of x2. So obviously we can now find the value of x1. So x1, we have already found x1 equal to m2 upon m1 x2. This is equal to m2 upon m1 x2. We have got 2f by k into m1. This was m1 divided by m1 plus m. So here m1 gets cancelled. So we have 2f by k into by m1 plus m2. So this is the value of x1. So this is x1, this is x2. So find the maximum elongation of the spring, elongation that the spring will suffer and the distances moved by them, right? And what was x1 plus x2? x1 plus x2 was 2f by k. This is answer 1, answer A, maximum elongation. This is the maximum elongation. This is the first answer. Maximum elongation is x1 plus x2, and the values of x1 and x2 separately. This is given here, right? Now, we shall go to the next problem also, because next problem says consider the situation in the previous problem. So it is better to do it here only continuously. Situation in the previous problem. It says consider the situation in the previous problem. Suppose the block M1 is pulled by a force F1 and the other block is pulled by a force F2. That means in earlier case, both were pulled by the same force. Now, left-hand side M1 is pulled by F1 and right-hand side M2 is pulled by F2. Here they want to us to find out the maximum elongation that the spring will suffer. They do not want us to find out x1 and x2, just the maximum elongation. So we shall do it continuously with the earlier problem. In earlier problem, mind it, we got this equation here that work done f x1 plus x2 is equal to half k x1 plus x2 square. Now what is the work done? Now work done is f1 x1 plus f2 x2. That is the only difference, nothing else. So now here, now work done is work done is equal to f1 x1 plus f, and total elongation is also total elongation is equal to x1 plus x2. Then what we are left with? Then obviously we are left with. So work done F1 x1 plus F2 x2 is equal to half k x1 plus x2 whole square. So earlier it was like this. Earlier this was the equation. F x1 plus x2 equal to half k x1 plus x2 whole square. Now the equation is a different equation. Now the equation is f1 x1 plus f2 x2 equal to half k x1 plus x2 whole square. This is the only difference. And the other equation which we got here, that m1 x1 m2 x2 m1 x1 equal to x2 m2 x2 remains unaltered, because the arguments, that is the instantaneous velocity of m1 and velocity of m2 and their momentum, they are equal and opposite, so m1 x1 equal to m2 x2 remains same, right? So we write also m1 x1 equal to m2 x2. This remains good, as it remains as it was, right? In that case, now we just solve the equations like we have done earlier. In that case, from here we get, so similarly we find m1 is equal to m2 by m1 x2. Now we go to this equation, say equation 1, from equation 1, what do we get from equation 1 is f1 x1. x1 is m2 by m1 x2 plus f2 x2 is equal to k by 2 x1. Again, x1 is m2 by m1 x2 plus x2 whole square. From here we get, take m1 as the denominator. We have got f1 m2 plus f2 m1 whole thing multiplied by x2 equal to k by 2. Once again, we have only this is equal to we have m1 in the at the denominator. This will be squared, m1 squared. In the numerator we have m2 x m1. In the numerator we have x2 square also we take outside. Then the numerator we have m1 plus m2 whole square. I think this is very clear. M1 is a denominator I have squared here. X2 I have taken out, squared here. And numerator I have M2 plus M1 whole square. M2 plus M1 whole square. So this X2 gets cancelled here and I am left with only one X2. Right? And then what is the value of X2? Therefore, X2 is on the right hand side. So I have to do a cross multiplication. F1 M2 plus F2 M1 divided by M divided by M1. This was M1 divided by M1. That multiplied by 2 divided by K and then multiplied by, I have to do a cross multiplication. M1 square divided by M1 plus M2 whole square. This is equal to, now what I am left with. This M1 gets cancelled with M1 square. I am left with only M1. So I have 2M1 by K. 2M1 by K multiplied by F1 M2 multiplied by F1 M2 plus F2 M1 divided by M1 plus M2 whole square. So this is the value of X2. Right? This is the value of X2. And then what is the value of X1? So X1 is equal to, we have earlier found, M2 by M1 X2. So if we multiply this by M2 by M1, so only this M1, M2 by M1, so this M1 will be replaced by M2. So this is equal to 2M2 divided by K. Remaining thing remains same. F1 M2 plus F2 M1 divided by M1 plus M2 whole square. Now the question is, find the maximum elongation. Maximum elongation is nothing but X1 plus X2. Maximum elongation equal to X1 plus X2 is equal to, on both X1 plus X2 you find this part is same. This part is same. So I have 2M1 plus M2 by K. So this is equal to M1 plus M2 by K multiplied by, this part remains same, F1 M2 plus F2 M1 divided by M1 plus M2 square. Now this M1 plus M2 and M1 plus M2 whole square gets cancelled and I am left with only M1 plus M2. So the answer, this is equal to 2 by K multiplied by F1 M2 plus F2 M1 divided by M1 plus M2. So this is the answer that they wanted. The maximum elongation, which is X1 plus X2. right? Now we shall go to the next question.